Welcome back, everyone. We're going to be solving LeetCode 1161, maximum level sum of a binary tree. So we're given the root of a binary tree. We need to return the maximum level sum, which would be running a breadth first search on this tree. So example 1, right, the very first level will have a sum of 1, the second level will have a sum of 7 plus 0, which is 7, and the sum of level 3 will have 7 plus a negative 8, so that would result in a negative 1 for the sum. So we want to return the level which has the greatest sum. Okay, so we are going to be using a breadth first search to solve this, so we will import dq from our collections library. So from collections, import dq. We'll set that up to be q dq containing the root, and we are going to have a resulting output, which is initially going to be set to the float value of negative infinity. And every time we run through our breadth first search, right, we run through a level, we're going to calculate the sum. If that sum is greater than this resulting sum, then we can change the resulting sum to the sum that we currently found. So now it's just a matter of running our breadth first search. So we'll say while the length of our queue still has items on it, we are going to set up a level, which will be equal to an empty array, and we will say for I in range length of our queue, we are going to grab the node with queue.popleft, and we're going to check if that node is not none. What are we going to do? We are going to say, actually, let's change this from an array to a level sum variable equal to 0. So when we get this first node, we're going to check, make sure if it's not none, and then we're going to just take its value and update the level sum to be that value. So we'll say level sum plus equals node.val. Now we can just append our left and right children onto our queue. So we'll say if node.right is not none, what are we going to do? Queue.append that node.right child. Do the same thing for the left child. Is not none. Queue.append node.left. Okay, once we exit this for loop, we've run through all of the elements in our queue for this iteration, for this level. So what we now can do is check, right? We've accumulated, for every node in our level, we've accumulated a sum. What do we have to do? We have to check to see if this sum is greater than our resulting output sum. If it is, we're going to update this sum. So let's do that. We will say if the level sum is greater than our resulting sum, we will change our resulting sum equal to the level sum. And wait, what's the output? The output, okay, the output is the level. So we're going to do this. We are going to also set level variable in here, and let's change the data we add on our queue to be a root and the current level, so we can grab this and update accordingly. So that means we're going to have to add the levels on when we add our children as well. So this will be level plus 1, and this one will be level plus 1. Okay, let's see here. Node level queue.pop left. If node is not none, we increment our level sum. Okay, so now we can come back down to here. If our level sum is greater than this output sum, we're going to change the output sum to our resulting level sum, and let's say the total. Let's say the total, or the level. Return level is going to be initially set to 0, right? So whenever we update this, we know we found a level that has a better sum than this resulting output variable. So we should also change the return level to be equal to the level that we are currently at. So we can say level, And then all we have to do is just return the return level variable. Okay, this is looking pretty good, so let's run this. It should be collections, not collection. Perfect, we passed in both test cases, so let's submit. And it does run, it's awesome. Time and space complexity. Time complexity is going to be O of n, right? We are touching all of our nodes at least one time within our tree. Space complexity is going to be bound to the length of our queue, right? Queue.length. All right, that'll do it for LeetCode 1161.